All right. Hello, my name is Gavin Hayes. Professionally, I've mostly done embedded programming, but I also like to write Perl for fun, and I've been working at a WebAssembly startup for a little over a year now. That WebAssembly startup is called Dilipso, and they are why I'm able to attend TPRC this year. Our company's goal is to take WebAssembly to production and keep it there wherever you want to run it. To do so, we have an open source framework called Extism that will be featured in this talk. Building on top of Extism, we are working on a software as a service platform called XDP to handle plugin uploading, storing, validation, testing, and much more. We also build tools for improving Wasm debuggability and observability. Today, we're going to talk about how WebAssembly might be useful outside the browser, specifically in Perl. One of the main reasons you might want to use WebAssembly is extending Perl. But before we talk about WebAssembly, about using WebAssembly to do so, let's talk about extending Perl more generically. Here are some common reasons you might want to extend Perl. When I talk about extending Perl, what I mean by extending Perl is not just integrating a module from CPAN, but integrating a library from another programming language. The main reasons you might want to do this are the functionality isn't implemented in Perl, access to API is not available in Perl, you want faster implementation than what's possible in Perl alone, code reuse. You might have code already written in a different programming language and want to use it in Perl without rewriting it. The common ways of extending Perl is XS, extendable subroutines, and FFI, foreign function interface, at runtime. The most used and oldest method of extending Perl is, of course, writing an XS extension. This provides a lot of power, but is very error-prone between issues building, linking, and at runtime. FFI Platypus's description puts it well. XS is less of an API and more of the guts of Perl splayed out to do whatever you want. That may at times be very powerful, but it can also be a frustrating exercise in hair pulling. The more modern way in many programming languages is FFI. FFI stands for Foreign Function Interface and handles converting types and calling conventions between the host language and the guest language. In Perl, Graham Allis's FFI Platypus is the way to go. FFI doesn't require writing glue code in C and compiling a native library to link in Perl. However, it's still prone to issues with building, linking, and at runtime. Building a language, especially one that isn't C in a CPAN module, often isn't trivial. Likewise, with extending XS, you're still running native code, so you're opening your memory-safe Perl program up to whatever vulnerabilities of whatever library you're importing. WebAssembly, or Wasm, is a portable bytecode that's supported almost anywhere. Many programming languages can be compiled to Wasm. Despite the name, it doesn't assume a web environment, so it's fit to run on the server and on the desktop too. Let's take a look back at the list of the reasons to extend Perl and see what can be achieved with Wasm. Almost all of them. The only extensibility reason that Wasm probably isn't your answer is access to API is not available in Perl. Wasm is by default completely sandboxed from the rest of your program, so there's no access to syscalls or system APIs. Due to the occasional demand for access to those APIs, there's a standardized effort to provide a restricted system interface to modules called WASI, or WebAssembly System Interface. Since you might be wondering how speed can be achieved over Perl when WebAssembly, like compiled Perl, is a bytecode, speed can be achieved by using a WebAssembly engine with a just-in-time compiler to build to native code then. In theory, WebAssembly can be compiled to just like any other target. Unfortunately, in practice, this isn't always the case. The Rust toolchain has WebAssembly targets supported fairly well. And for C and C++, there's a WASI SDK Clang-based toolchain that I recommend. But there are other options. Unfortunately, to my knowledge, there isn't an active port of Perl to Wasm. There has been some success in the past getting it to run in the browser with the emscript and toolchain. Your experience building a library to Wasm will vary based on the toolchain support and what the code you're porting is actually doing. A general rule of thumb is pure or compute-only code translates very cleanly. Code that relies on syscalls, threads, or forking, not so much. Though some of this is a part of WASI and is evolving. All this talk about the challenges building to Wasm probably didn't make using native deps in Perl, using it for native deps in Perl sound very appetizing. You should still consider doing it, as it can make your application more secure by running less native code and portability. Your module doesn't need to involve platform detection, compiling, and linking. Everyone can just use the same Wasm module, you just have to build it once. Due to it varying by what language, toolchain, and the code you're trying to build, the rest of this talk is going to focus on how to integrate Wasm into Perl rather than how to build Wasm. The Wasm package is built to make writing Perl extensions in Wasm easy. This works great for passing numbers around, but quickly becomes dicey when strings or structs get involved. Let's go through an example of passing a string into Wasm and getting a string back. Here in this Golang program, we have a function, countVals, that takes an input string, counts the number of vowels in it, and returns the count as a string. How do we call it? WebAssembly basically only has numeric types. So to pass a string into a WebAssembly function, it must be done by pointer. And similarly, to return a string, it must be returned as a pointer. Unfortunately, this leads to writing some non-idiomatic Go code to convert to and from pointers. To export countVals to the host program, we export a function that takes two parameters, a pointer and a length. Pointer to string creates a new string from the pointer. Then we call the real countVals. Then we call pointer to leak string, which mallocs a buffer and copies a string to it. Finally, we return the pointer and length as one uint64 integer to avoid needing multi-value return on the host side. For now, this is how it works, as WebAssembly is standardized on a 32-bit address space, so both values can fit in one unsigned 64-bit integer. Now let's call it from Perl. How do you pass a string into Wasm? Passing a pointer value to a string in the host program isn't going to work, as WebAssembly is a virtual machine. So it has its own address space, and the string would not be allocated from the same pool of memory, thus would be unaddressable from the WebAssembly. At the moment, there's no standard way to pass complex data types into Wasm. If your Wasm module exports its memory includes the C standard lib, then you can often call the Wasm's malloc and then copy into it, and hopefully you free that block later. For the purposes of demonstration, this attempt at calling countVals has three major bugs. Failure to check the return value of malloc. It could return null if there's no memory left. If this was a null pointer, we just wrote to the Wasm's address 0. Note, we wrote 1 byte beyond the block we allocated, as we only allocated 4 bytes to store 5 characters. Leaking memory due to failure to call free. We never freed our input data or the return pointer. Just to be clear, this isn't a dig at the Wasm Perl module, just pointing out some of the usability challenges with WebAssembly. Something as simple as passing a string requires practically C programming inside of Perl. An alternative to writing C in Perl to pass strings is the Extism framework. Before I explain more, let's revisit making a countVals Wasm module and calling it in Perl. The val counting code is exactly the same. Now our program is using Extism to retrieve the input and output the value. With the Extism Perl SDK, we can just pass our string and a string is returned. Extism handles the memory management. We aren't forced to think about pointers in our Perl program. What is Extism? Extism is an open source cross-language framework for building with WebAssembly. On the host side, Extism offers SDKs for a variety of different languages and environments, as I just showed, including Perl. On the guest/Wasm or plugin side, Extism offers plugin development kits or PDKs that can run in any of the host SDKs. The main unit of Extism is a plugin, a Wasm module using the Extism ABI. The plugin object enables calling Extism functions. Extism functions always take an input string and return an output string or buffer. How you serialize your parameters or deserialize the return data is up to you. In case anyone was curious how specifically the Perl SDK works, Extism's main runtime is written in Rust, but exposes C bindings to its functions as a native library called libexism. The Perl SDK is made up of two CPAN distributions, Alien libexism and Extism. Alien libexism uses Graham Allis's excellent Alien build platform for easily installing native libraries. The Extism distribution is made up of two packages, Extism XS and Extism. Extism XS wraps libexism, and Extism provides a more Perl-friendly interface. If I were to rewrite it, I probably would have used FFI instead of XS, as the XS ended up being pretty hairy, and I didn't realize FFI can work even with static linking. If you're wondering why I care about static linking Perl, see my next talk right after this. What else is WebAssembly useful for? The ability to safely run code, even untrusted code, is useful beyond sandboxing dependencies. If you have the ability to safely run untrusted code, you can make a plugin system, specifically a secure plugin system. Think beyond desktop applications. For example, in the context of a software as a service or SaaS, a plugin system can possibly offer deeper integration than webhooks without the latency of API calls. As you may have expected from the plugin being the main unit of Extism, Extism is tailored to creating plugin systems. Let's make a pluggable Perl module or a Perl module with a plugin system. We'll make an audio decoder module, as this will demonstrate seamlessly integrating native code with Perl too. To keep it simple, it'll only be able to open audio files, retrieve audio metadata, and decode audio data. The plugin interface, in this case, will be pretty similar, but rather than allowing the plugin to access our file system, we'll copy the audio data into a buffer and pass it into it. New takes two parameters, a file name and a list of decoder plugins to try. It loads the file into memory, it iterates through the decoder plugins, calling the open memory function with the audio data. If the open memory function returns a trophy value, we create an object and store the return value as it's our handle to the decoder. Otherwise, we try the next plugin. Get metadata calls the get metadata function in the Wasm. Get metadata calls the get metadata function in the Wasm and decodes the response as JSON and returns the result. Decode calls the decode function in the Wasm and returns the raw PCM audio data. With the host interface decided, we can make plugins for it. Let's look at the FLAC plugin for decoding FLAC audio. It's written in C and uses David Reed's single header FLAC decoding library. Open memory copies the audio data from Extism's input buffer into a malloc buffer, initializes the decoder, copies the pointer of the decoder to Extism's output buffer. Get metadata loads the pointer to the decoder from the input data buffer, uses snprintf to hastily encode JSON, and then copies the JSON to Extism's output buffer. Finally, decode loads the pointer to the decoder from the input data buffer, decodes all the audio, and copies the audio to the output data buffer. That's all to this plugin. As all the memory is used by the WebAssembly will be freed when the plugin goes out of scope, I didn't bother writing cleanup code for freeing the decoder objects or the input audio data. I'll skip showing the full source for the wave decoder, as this plugin was also written in C and uses a wave decoding library by the same author that wrote the FLAC decoding library, so it isn't all that different. Finally, here's an example program using the decoder. This script takes a path to an audio file as a parameter. Extism audio decoder attempts to open it, and if it doesn't work, tries the wave decoder. It queries the audio metadata, printing it out with data printer, decodes the audio data, and lastly saves it to a new file, the input file with .pcm appended, as this is raw pulse code modulation audio without any header. We could run this on a server accepting decoder plugins from third parties and not worry about it compromising the server. Of course, I'd want to configure a timeout in Extism on running plugin functions, so a denial of service attack couldn't be run on the server just by uploading a plugin with a function with an infinite loop. Thank you all for coming. The Extism module is on CPAN, but here's a link to the Perl SDK repository where the examples can be found, and also a link to the Extism Discord for community and support. Any questions?
Yeah, you mentioned the Extism framework does its own memory management stage. I don't have to worry about that. I assume that's Wasm GC stuff.
No, it is not. Oh, yes. So I was asked if Extism uses Wasm GC to do its memory management. Extism is not dependent on Wasm GC or any of the specialized extensions. How it passes memory is using those primitive types in a loop, it copies the values. And you'd think that there'd be a performance with that problem with that, but we haven't actually seen that for any of our use cases. Yes?
What are some of the other interesting languages you can target to Wasm that Extism supports to integrate into the Perl SDK, for example?
So we showed off Go. Oh, yes. So I was asked what languages can also target WebAssembly with Extism. So in this presentation, we showed off Go and C, but you can also use Rust, JavaScript, Zig. There's a brand new language called Moonbit that someone in the community contributed recently. I think it's about 8 or 9 languages right now.
So the method that you use requires some knowledge of the guest language?
Yes. So each guest language has its own PDK, or the plugin development kit, that wraps the WebAssembly imports. Yes.
So I assume you are using what you just showed in your startup for audio video. Is there any other use case you have in mind on you where that could be also super useful?
One use case is, so I got asked about like other potential use cases for Extism, and besides audio video. We've seen some people use it for like templating engines of being able to use like JavaScript, React template stuff without it being a JavaScript application. And so you could use those frameworks elsewhere. Yes?
What's the performance on that?
I don't have any benchmarks handy right now, but especially once you've loaded the Wasm module, it runs in microseconds usually. All right.